Hello guys, welcome to the channel. Today we will discuss DBSCAN clustering. So what is DBSCAN? DBSCAN stands for Density Based Spatial Clustering of Applications with Noise. Okay, it is an unsupervised machine learning algorithm used for clustering. Okay, so unlike K-means, what DBSCAN do? DBSCAN does not require the number of clusters beforehand. Okay, it can detect irregular shaped clusters. It can also identify outliers or noise points. Okay, so these are some benefits of DBSCAN. Okay, so let's understand this using a real life idea. Okay, imagine people standing in a park. Okay, so areas where many people stand close together, it will form a cluster. Okay, understand this. In a park, people are there are so many people standing. Areas where many people stand close together, it will form a cluster. And people standing alone far away, that is an outlier. Okay, understood this? So DBSCAN works exactly like this. Okay, it groups points based on density, where many people stand close together, it will form a cluster. And people standing alone far away, it will consider as an outlier. Okay, understood this? So So basically, in DBSCAN algorithm, we generally use only two parameters. Epsilon, eps means the maximum distance between 2 points. Okay, to consider them neighbors. Okay, think of it as a radius around a point. Okay, if another point lies inside this radius, they are neighbors. Okay, and second one is minimum points. Minimum number of nearby points required to form a dense region means cluster. Okay. For example, I have taken mean samples is equal to 5 means at least 5 points should exist nearby to create a cluster. Okay. So that's what it means. So let's see how we can perform DB-scan clustering practically. Okay. So this time I will import a dataset from Scikit-learn only. Okay. So first I will import some required libraries as PD, import matplotlib dot pyplot as PLT, import keyboard as SNS. And from Scikit-learn datasets, there is a make moons dataset, which is a type of which is a problem of classification dataset. Okay, import make moons. Okay, I will show you by plotting a graph. Although, okay, so let's take x and y, and I will call my dataset make moons. Okay, now suppose I will take some n samples. N samples means total records. How many rows you want to take? Suppose I will take 250. Okay, I'm taking 250. What noise you want to add in your dataset? Suppose I'm taking 0.05 as my noise. Okay, now let's see my x. So here you can see there are two columns forming into my x. These are my input. This will be my input. Okay, this is my x. There are total two columns. Let's see why. And this is my output. Okay, this is my output. Let's store this. Okay, how we can store this? Because I will keep this here. I will suppose I will store this. Suppose I will take df is equal to, I will make a dictionary. Suppose I will take column one. So So in column one, I will take the first column of X. See, there are two columns I have shown you into my that was into my X. Those were my input columns. So first I will take my X. First column will be my give me total rows and zero means give me the zero means give me the first column. Okay. In column one, I have taken the first column, and in column two, I will take I will take X X second column. That is one. Okay. So X I have taken column one, column two, and let's take Y, and it will be my Y. Okay. Okay. Let's give this output. Okay. There are three columns: column one, column two, and column three. X X first column is my input column, X second column is my input column, and third is my output column. Okay, let's take this. Now let's create a DF train. DF train, I will take my input columns, right? These two are my input columns. Okay, I have taken my input column. Now input columns are there in my DF train. Okay, now let's transform this into data frame. Data, let's take data train as a variable, okay, called pd dot data frame, data frame. Now I will give df train. I am transforming to data train. I am transforming data train to my df train. Okay, okay. Now I will transform df also. Let's take data. Data is equal to pd dot. Again, I will call data frame, and then I will call my df. Okay. Now let's check how is your data is looking. Data dot head. Cool. See, it is my first column, it is my second column, and this is my output column. Okay. In df train you have, let's sorry, data train dot head. I will show you this also. Yeah. In data train I have input columns. Okay. Now let's plot a graph. Let's plot a scatter plot to see the data, to see how data is distributed. Okay, let's give x is equal to column 1, y is equal to column 2. Okay, let's give data as data because my main data is in my data variable, and q parameter I will give output. Okay, output I will give plt dot show. Yeah, this is how my data is distributed. Okay, now let's build a model. Okay, let's from scikit-learn dot cluster import dbscan dbscan. Okay, I have imported my dbscan. Let's make an object to call dbscan. db is equal to db. I will I will Let's make an object to call db. Okay, now I will give my parameters. What parameters we generally take? We take epsilon, which is my radius, and minimum samples. Okay, means at least like minimum number of nearby points which we require to form a dense region. Okay, now uh, let's take EPS is equal to 0.02. Let's take this. Okay, let's take 0.2. Okay, and let's take minimum samples as 5. Let's take 5. Okay, let's take this. Now I will predict db.predict predict predict. Okay, I will give my data train. Okay, this is my data train I am giving db.predict. So it predicted the outputs. Okay, you can see here it predicted the output through by training the model. Okay, now let's store this into my data train. Okay, we will compare by plotting the graph, my predicting graph and my actual graph. Okay, data train and I will take, suppose I am giving predict as a, I am storing these outputs in my predict column in data train. So I will simply copy this. I am storing this into my predict column of data train. Okay. Now, let's plot a graph to compare. This is my actual data, graph and my predicted graph. Okay, I will compare that. Now, SNS dot scatter plot. I will give x is equal to I will give x is equal to column 1, y is equal to column 2, and uh, I will give data as is this time I will give data train to compare for comparing. Okay, I will give data train. Now I will give view parameter as predict. Okay, predict. Now plt dot show. Now can you see the predicted graph here? And can you see the actual graph? Okay, so this is how we made predictions using DBSCAN algorithm. Okay, DBSCAN clustering. Okay, so this is how DBSCAN works. Okay, so that's all in this video. In the next video, we will discuss Scikit score. Okay, thank you.